We move on in this session, and it's traceability throughout the value chain. And the first speaker in that part of the session is Raul Carlsson, senior researcher at RISE Research Institutes of Sweden. Raul, I'm very happy to have you here. We've been colleagues before. Good to see you again. Warm welcome. And the floor is yours.
Thank you. Just testing. You can hear me, I guess. Good. Now we'll see if our screen share works as it should also. Always good to check before start talking. Wow, that was not the smartest thing to do. Now let's see how I do that better. So now I think it should not be a strange mirror anymore. Do you see
this should be working? Yes, we see the PowerPoint program. That's fine if you just move on.
Yeah, that's good. And now I put it into the presentation mode, and I think that
okay.
Also.
And you can also dölja den där lilla pluppen där.
That's good. So,
thanks. Nice to speak some Swedish.
Yes, dölja is a good word. In Swedish, we gotta find a better one. Traceability throughout the value chain, and I will talk about what has been done and what is ongoing in that area, and something about the technical aspects and standardization aspects, and so. I'll just see. So here, the contents, of course, traceability in general, electronics products in particular, why this is important, some of the challenges, global possibilities and feasibility, ongoing drivers and challenges reflected from initiatives in EU, and of course you usually end up with some short summary if I do not spend too much time. So I start with just reminding us why we are doing this. Most people think of their valuable whatever electronic or electric products as something very individual. They do not think about it as the actual material content that's in there. Plastics, aluminum, silicon, copper, everything that we know that we want to reacquire during the recycling stages. And also, again, people in general, they forget that everything here in this material comes from different parts of the world. And I'll show you this presentation because this is something I made quite early, maybe 20 years ago or a little bit less than that, when I started giving courses on life cycle assessment to remind everybody of that. Electronic equipment doesn't just start existing. They have to be, all the material have to be acquired from all over the world. And understanding that makes you aware of the fact that you better take care of this. You better make the best of all the materials during the lifetime of them. And of course, they have to be transported. So much of the world's transportation and production is just to acquire material, put them into some usable product, and eventually putting it out on the market. And usually this, as you can see, it's a bit old. It's the first version of iPhone, maybe second version of iPhone. Doesn't matter. I don't want to update the presentation part because this is something I usually use. And no one would produce an iPhone just because they want to use one of them. They do it because they want to really use a lot of them. And when I did this the last time, I updated it, it was 1 billion smartphones in the world. And it's quite a lot of material, 133,000 tons of material in these smartphones at that time. Just to give you a view of when you have something in your pocket, you would never have it if it was one. You only have it because it's thousands and thousands of tons of the same type of product. That's why you can afford to buy it, because there are so many of them that they can actually make it cheap enough for any one of us to afford them. And that means also that we do quite a lot of hauling around production all over the world, and we make big holes every here and there. And you can see these are really huge machines on the border of this hole mining area. And if we make materials from renewable resources, we replace a lot of natural ground with renewable whatever type of green crops. And when we need energy, we always need to, in some way, we've seen photovoltaics just in the presentation, but still we are strong dependency on fossil fuel throughout the world to make these chains work. And this is a picture of Shanghai. It's not a bad picture, it's just a bad Shanghai, because all the different materials, all the different hauling around of things are actually producing quite a lot of bad living environments. And we also have these waste dumps that everything end up with. Maybe that could be, maybe I have no idea how much electronic equipment here. Just reminding us that the whole idea with traceability is about understanding where things come from, understanding that we are tracing really big flows from everywhere into our pockets, homes, desktops, wherever, working places, and they end up in some kind of end of life treatment in the end. So how to stop this? Everybody's doing the best. Nobody creates waste because they want to. They only want to have a good thing, and they want to have the best version of it all the time. And of course, they will get rid of the previous version in some way. So traceability, what is it, and what is the scope of traceability when I present it? This is a very general picture, originally produced for textile, and then used also for metallic traceability, and then actually it's quite general. It's not very specific in all the details of a specific industry, but from the left here you can see virgin material coming from the ground is producing something, material that you can use for manufacturing products. And when the products are there, you put them on the consumer market, and the consumer can use them, and they can scrap them immediately after they have used them, the waste treatment, or they can leave them over to the recycling or sorting, or they can let them be put out on the second-hand market, maybe even to do domestic use. The kids are using them instead of me, and eventually you waste them or sell them on a global market if they are useful products. So all of these steps, you might want to trace the material so that you can actually see when you have a recycled material that it's being put into replacing some virgin material, and so you can use less virgin materials, less large holes in the ground, that's a sort of picture before, and replace it more with recycled material. So the whole idea is here to how to trace it all over these different steps. What are the possibilities, and what can we achieve here, and what are the drivers around that today? If you look specifically on the traceability of electronic products, and with the address on this conference, the waste of electric and electronic products, we see that to sort here, to recycle, sort effectively, most of the someone already presented before today in the session before that we cannot find one solution for all of the different electronics. They are very different. So to be able to recycle very effectively or efficiently, we want to know more about what are we having in our hands, how can we put this item apart, what can we expect when we open it up, what is the most efficient way to open it up, etc. So to sort it effectively, one need information about the product that is relevant for the next life cycle phase. Should it be put on the market again, maybe second or third life market? Should it be recycled into material that you can put into the next loop, or should it actually be waste? We would like to know that already when we start sorting our recycling waste. But to get that, one also might need to have this disassembly guidance. How do I open up my iPhone? How do I open how do I take apart the LCD screen or whatever product I have in my hand? To have that information while you're actually recycling and sorting could be very useful. Material content, of course, it's not only material how to use it in the end, but also material content as such. Have a list of are there even useful materials inside this inside this product. And of course, regarding its recyclability in general, who can even take care of these materials? Who is best at sorting them out? And all the types of waste treatment. Are they good for incineration? Should they be treated as toxic materials? What are the ways to treat the waste that you cannot really recycle, and we know that there is no market for? One has to have more knowledge about that. So these are the kinds of information that one would like to have more information about after recycling and sorting. And So to be effective, all this information needs to be accessible throughout the product life cycle. To begin with, if you think of it from virgin up to a product, when you throw it away, the old linear model, you would like to have it throughout the one life cycle. But in reality, you would actually like to be able to trace it all through the different life cycles, even if you have different markets. So that is this kind of scope of, and also the challenge for making traceability of electronic products work. So what are the possibilities to make this work? First of all, sorry, I probably covered that. What are the possibilities for traceability? Identifying an individual electronic equipment, item, something like a cell phone or a laptop. So if you're sitting without electronic support or digital support, you might just look at it visually. Okay, this is a laptop, this is a cable, this is an LCD screen. So the first thing is to just look at it to see what it is. If you're very competent, you might be able to just categorize a number of different things. You can also have an idea of brand name to more effectively understand what you're looking at. But then we come into possibility to make even better decisions. The part number, to know precisely what part number it is. And then you can, if you then can access information about that part number, the blueprint, for example, the way to disassemble, then you're actually in much better situation than just having the visual identity and the brand name. But if you're also getting more individual information, like the OCR, the serial number, the digital identifier, barcodes, data matrices, something that really makes you identify a specific item, then you could even get information about the quality check. So here is the information, here is the type of ways you can identify individual items, but here's the type of information you could get if you can really get into that specific information. So as I said, categorical documentation, like this is a laptop, part number, specific component structures, disassembly guidance, material list. And for individual items, you can actually get some background, get a history, where has this been used? Has it been updated in some way? And what is the quality? Should it not even be scrapped? Should it actually, it might be so good that it should be put back on the market to replace a new, to not have to be replaced with a new product. So these are very important. Yes?
Now you have 2 minutes.
Okay, good. So here is very important information to be able to both make them traceable, but also information that you can acquire. So where are we today about this? We did a study in 2019 on Internet of Materials, and we noticed that, okay, there are standards that you can use to identify materials, but what about the standards to share information like disassembly routines, etc., disassembly structures, material lists, etc.? And what we have there, we noticed that in order to make this information useful, to be able to share information about the disassembly structures, one need information about organizations that provide them. One need information about should we use QR codes. One need information about how to read these QR codes, and one need information about disassembly structures to really make this work together. And these international standards, we could see that there are some of them, quite a lot of them, but in specific, we lack a framework where you actually put these standards together so we can make them traceable, all these products. So this is one part we noticed, that we have a lot of standards that makes it possible to trace materials, but we do not have a specific standards that put them together. And in some way, this is what we are doing today at the EU level, the European drivers for global traceability. So at the European level, there are this is the Green Deal, the strategy for how the European Union will work with putting together the requirements on digitalization, on traceability. And they state that digitalization can help improve the availability of information on the characteristics of products sold. For instance, electronic product passport could provide information on a product's origin, composition, repair, and dismantling of possibilities. And this is a quite new document from 2019. So EU is in this level right now. And then we have this action plan of circular economy that was designed in 2020. It was released in 2020. Also talking about the digitalization of product information, such as digital passports, tagging, and watermarks. So here comes the drivers to make this possible. And this is a very new type of document that I show you. This from a workshop held in June this year. And it's about the EU presenting what do they expect from such digital passports, structured collection of products related with data, the decentralized system, scope, which is about circularity aspects, remanufacturing or recycling of system of products. And what they expect from that is that the citizens, public authorities, market surveillance, etc., should be able to use this material. And they expect it to also include information about aspects like chemical content, dismantling instructions, etc. And this is what the strategy for the EU is, to really make this possible. And it's coming a long way right now out on the discussion points. And here are some of the objections to it, some of the discussions that are ongoing. As I said, this is exactly right now. And some of the industry is saying that we do not want list of material structures, we don't want quantities of materials, etc. So this is in the discussion right now, that on the one hand, this is a strategy going on, and on the other hand, there is a discussion. This is an effort to kind of make this more less strong requirements. So summary, traceability is key to circular economy. As I say, globally and per material and product category, most components are there to practically enable global traceability. So we have it. There are far-reaching initiatives in EU to drive the standardization. And as I said, that's the reason why I say that there are some objections and discussions right now. Final words are not said, but circular resource management must be met. So this is where we are. So sorry for being tedious.
Not a problem. It's very interesting. Thank you for bringing this forward so that we know what is happening and what is the latest now from the EU and the Green Deal discussions to create these standards and how to do it. So stay with us. And